Hi, in this session we are going to discuss about mechanical translation system problem. So first I will read the problem. Write equation of motion in S domain for the system shown below. Determine the transfer function. So they have given a mechanical translation system. We need to find a transfer function for the given system. So you can find a spring, a dashport and a mass element. So we have to find the transfer function. In order to find the transfer function, we have to find nodes. So in this particular example, we can consider mass element as node and of course a spring and dashport connected. Hence, we need to assume that a mass element is in between these two components elements, and we have to assume that mass element value m is equal to 0. So this is the initial assumption, and as far as this problem concerned, K is spring constant, B2 is friction of dashport, and B1 is friction because of the mass element is lying on the reference. And other assumptions are Laplace transform of x of t is x of s, Laplace transform of f of t is f of s. Here input is force, this is input, and output is displacement x of t. So here we are considering displacement with respect to mass element m. This is the basic introduction with respect to this arrangement. First, we are considering node related to m, mass element m. That is actually free body diagram of diagram at node m. So we need to find number of forces acting on this node. So here one applied force is there and other forces are opposing force. Hence, f of t is applied force and Fm opposing force related to mass element m. Fb1 is opposing force related to friction, this one, and Fb2 is the opposing force related to the dashport. Okay, now we need to write the equation related to opposing force. Fm, f suffix m is equal to m into dx by dt square. Fb1 is equal to b1 into dx by dt, and Fb2, that is force acting on the dashport. This is in between mass element m and another mass element which we have assumed is in between K, that is spring and dashport B2. So the displacement with respect to mass element is x of t, and displacement with respect to mass element, this one m1, is x1. So Fb2 is equal to b2 into dx minus x1 by dt. By Newton's second law, the force balance equation is, that is, sum of all the forces on the node is equal to 0. That is, sum of applied force and applied force is equal to opposing force. So applied force is f of t, one applied force, that is equal to sum of opposing force, that is Fm plus Fb1 plus Fb2. Now we have to substitute the equation related to all these forces. Now when we are substituting, we get m into dx square d square x by dt square plus b1 dx by dt, b2 dx minus x1 is equal to f of t. Now we have to take Laplace transform of this equation. So Laplace transform of this one is, this is second order differential equation. Hence m into x is s square into x of s. Laplace transform of this one is b1 s into x of s Laplace transform of the third term b2 s into x of s minus x1 of s, which is equal to Laplace transform of f of t is f of s. Now we have to rearrange the equation so that we can take x of s and x1 of s. When we are rearranging it, we get m into s square plus b1 into s plus b2 into s into x of s minus b2 s into x1 of s is equal to f of s. So we are going to consider this as equation 1. Next one is, I told you that we have to assume a node is in between the spring and dashboard, and we have to assume that mass element value is equal to 0. So free body diagram related to this assumed node is, here there are two opposing forces are there. One is related to spring and another one is related to dashboard, and the displacement with respect to this node is x1. Here k, that is spring, is connected with the reference and dashboard is in between this mass element and mass element m. So we need to consider displacement x of t and x x1. Hence fk, the equation related to these two are fk is equal to k into x1 and fb2 is equal to b2 divided b2 into dx1 minus x divided by dt. Now using Newton's second law, sum of these forces, that is sum of forces acting on the node, is equal to 0. So there are two forces, opposing forces acting on this node. So fb2 plus fk is equal to 0. Now we have to substitute this equation. We get b2 dx1 minus x by dt plus k into x1 is equal to 0. Now we have to take Laplace transform of this equation. We get b2s into x1 of s minus x of s plus k into x1 of s is equal to 0. Now again we have to rearrange with respect to x1 of s and x2 of s. So when we are taking x1 of s one side, then we get b2s plus k x1 of s minus b2s x of s is equal to 0. So again we have to rearrange and to get x1 of s. So when we are we are moving this one right hand side, we get b2s plus k into x1 of s is equal to b2s into x of s. Now we are going to solve for x1 of s. So x1 of s is equal to b2s divided by b2s plus k into s of s. We are going to consider this as equation 2. So we have two equations. One is here, first equation, and second was here. Now we are going to substitute second equation in the first equation we get. So that is, we are going to replace this x1 of s by equation 2. So there is no change in this, the same is repeated here, and b2s instead of x1 of s, we are going to substitute this equation, that is b2s divided by b2s plus k into x of s is equal to f of s. Now these two are common, or x1 of s. So I am going to take x1 of s outside. When I am taking x1 of s outside, this one minus b2s and this factor is equal to f of s. Now we are going to cross multiply this one, okay, and we are going to make denominator same. When I am doing that, so I get this one, and I am going to multiply this the denominator component here. So b2s plus k minus b2s into again b2s is equal to f of s divided by b2s plus k. So x of s into, so this is the multiplication, minus we have 2 b2s, so b2 square into s square divided by b2s plus k is equal to f of s. So we need to find the transfer function. Transfer function is equal to Laplace transform of output to Laplace transform of input. Here input is force and output is displacement. So output is displacement, Laplace transform of displacement is x of s, and it puts force f of t, Laplace transform is f of s, which is equal to, so I am going to make this is denominator divided by this 1, so I will get, there is no change, okay. So this I am going to make here, so I will get x of s by f of s equal to b2 plus k divided by m into s square plus b1 plus b2s into b2s plus k minus b square s square, and this is the transfer function of the given mechanical translation system. Thank you very much.